Okay, this is chapter 6.5 to 6.6 of mechanics, and it's only 6 questions, but they are not short and easy peasy cheeky questions. بالعكس, they're a bit longer. Okay, with these questions, there's more than one step, and the questions are they require you need to understand what's going on. Okay, unfortunately, for some reason, since our school is so like organized and whatever, this material isn't even required for AS Mechanics. These questions are actually required for a course called Further Mechanics, which is part of Further Math. So I don't know why the school gives us and teaches us these things, but we don't have a choice but to solve and do the exam. But it's not that hard. This section is very easy. Okay, so let's start. You have a small drawer, 60 centimeters in width and 80 centimeters in height, as shown over here. It's resting on a rough surface. Keyword is rough. Okay, so what does that mean if it's rough? There is friction, right? Okay, as shown below, a horizontal force, F, is applied to its top corner, as shown there, and they told us the weight is 160. What did they tell us? They told us the center of mass is at its geometric center. Draw the free body diagram. Without looking over here, okay, I want to show you how it's gonna look. Okay, so you have, this is the drawer over here. Okay, you have obviously a force, and they told us في force هون it's acting, and we don't know, we just call it force F, right? Obviously the most obvious one is we have a force F here. What are the other forces that are acting on the box? Okay, أول شيء we said that there's friction. مجرد ما you're pulling it to the right, يعني the friction is gonna oppose it in what direction? It's gonna go in the opposite direction, right? So this is the first thing. The second thing, they told us its weight is 160 newtons. What will people do? People are gonna put the weight over here. Why is this wrong? Where does the weight of any object act? It acts at its center of gravity. And they told us that the center of gravity, or the center of mass here, is where? At the geometric center. So the geometric center is where? Over here, the center of the circle, of the square, sorry. So the weight will look like this. Okay? Type. What will people do now? Obviously, it's resting on a surface. So there will be a normal reaction N, right? Normal reaction N. So what will people do? They're going to put it here. Why is this wrong? If you want to think about it, but I'm going to tell you why. When you're pushing the drawer with a force F, yeah, with the force F like this on the corner, on the top corner, what's going to happen to the box? It's going to go and tilt and topple and rotate to look like this. Isn't it going to rotate like this? And the only point of contact will be the corner, right? After you rotate it. It's force F, and the weight is still acting like this. Actually, no, the weight in this case will be like in the middle, go down. The weight will still be like this, right? Ooh, there's no more friction over here. So when you apply this force F, it's gonna be tilted, and the only point of contact will be here. So where will the normal reaction occur? Since you're applying this F, the normal reaction will be over here. Is this true for any box? No. Why is it true here? It's true because, like I told you, you're applying the force F. You're tilting it. حتى they said here, it's on the point of slipping and it may topple. Topple يعني to turn and like to rotate like this. Okay? So for that reason, when you have the case of a force being applied in the corner or some moment like this, your normal reaction will be over here in the corner. Okay, so this is FBD part A, very easy. Type. So it's obviously not this one because the friction is wrong. So it's either this or this depending on the normal force. Hatta here, this is wrong because the weight is going up. That's pretty obvious, right? It's gonna be wrong. When is weight pulling you up? Okay, so even if you don't know about the normal, by process of elimination, this is correct. طيب they want you to find the magnitude of F. I think it's very easy. So what do we know about, we have the free body diagram, so like we know what to work with, and they gave us the dimensions command, they gave us all the distances, we just need to find, like حتى they gave us the magnitudes of the forces, which is amazing. What do we need to find? The only thing we need to find is the magnitude of F. What do we have given? They told us it's on the point of slipping and may topple. This means that at this instant the sum of moments is equal to 0. It's in what we call rotational equilibrium. Okay? It means that the particle is about to rotate, it's on the verge, it's on the point, so the sum of all moments in this case equals 0. طيب, since we know that sum of all moments is equal to 0, can't we easily find each moment and just add it and equal to 0 and then find how much F is? Of course we can. Yalla, let's start. We have, as you can see here, this is why they asked us to find the free body diagram. We have 4 forces, so let's find the moment for each one. Someone's gonna come and ask me, he's gonna tell me, Walid, around where are we rotating? I think you're not stupid. So when you come and rotate a box with this force, you push it with this force, you pull it with this force, it's obviously gonna go on this point here, right? It's gonna rotate around the point that's vertically under it, right? It's gonna go around this. So let's call this point O, and we have all the dimensions. We know this is 0.6 meters and we know this is 0.8 meters. I think we can find everything now. Let's start with the first moment, the moment of the force of friction about O. It's gonna be 0. Why is it 0? Look at the force of friction. Doesn't it pass through O? Yes. طيب, the moment of the force of the weight, let's say the weight around O. طيب, if you look here, O is already perpendicular to the line of action of the weight. So do we need to resolve into any components? No, we do not, right? Yeah, as I was saying, I think I cut off, but the moment of the weight about O, you don't need to resolve it since the line of action of the weight here, it's already perpendicular to O, right? Extend O up, extend O to the left, as you can see, it's already perpendicular. So we don't need to resolve. So it's just going to be equal, remember that moment is equal to plus minus F times D. Either one of these have to be perpendicular, okay? In this case, the distance is perpendicular, not the force. If you draw to the force, it's gonna be at an angle, as you can see here. But in this case, it's already, the distance is perpendicular. Anyways, let's not talk too much. It's already perpendicular, so let's find the moment. Its direction will be like this, right? So it's gonna go counterclockwise. So it's gonna be positive if it's counterclockwise. The force of the weight is 160 newtons. The distance is 0.3 meters. How is it 0.3? Because all of this is 0.6, right? So all of this is 0.6. This is to the center, so it's obviously halfway. So it's going to be 0.3. They told us it's the center. Anyways, this is going to be 160 times 0.3, 48 Newton meters. Let's take a look at the moment of the normal around O. Obviously, it's going to be 0 because it intersects the line of action of it, intersects the point of rotation, the center of rotation. If you take a look at force F, the moment of F around O, let's take a look. If you draw to the force F, it's already perpendicular, right? So we don't need to resolve. We're trying to find the force F, so we don't know it. Yeah, so let's find its moment. How much will this moment be? Plus minus FD. In this case, what's the direction? Always you say the direction first, so you know if it's positive or negative. It's gonna go what? Around O clockwise, right? So it's gonna be negative. Its force is F, we don't know how much it is. Its distance is vertically how much? 0.8 meters, so minus 0.8 F. What do we know? That the sum is equal to 0, right? Oh, not here. Over here. That the sum is equal to 0. Why? Because it's in rotational equilibrium. So you're going to say 48 minus 0.8 F is equal to 0. You're going to get F is equal to 60 newtons. Okay? Very easy. What is the magnitude of friction on the drawer? Before going to part C and solving the friction, I just want to recap what happened here, okay? Over here for part A, we worked with sigma m is equal to 0, okay? Why am I doing this is because we have a moments question and they're talking about the point of slipping and it may topple. As soon as you see this, know that you have rotation equilibrium. And the first thing I think about with rotation equilibrium is sigma m is equal to 0. But now for part C, you're gonna see rotational equilibrium is another form of equilibrium. The only thing added to it is rotational, which is why sigma m is equal to 0. So, okay, usually in equilibrium, what do we have once an object is in equilibrium? Sigma fy is equal to 0 and sigma fx is equal to 0, remember? So rotation equilibrium is just equilibrium, but you added to it that sigma m is equal to 0. So now for part C, the magnitude of friction. If you take a look at our work over here, anything that involved friction cancelled out. So aslan, if you think to yourself to use sigma m equals 0, you're going to see that the moment of friction is 0. So there's no way you can find how much the friction is. Okay, so that's why here we're going to use sigma fx is equal to 0. Friction is a horizontal force, صح? So let's take a look at the block. Since sigma fx is equal to 0, what horizontal forces do we have? Anything acting to the left is F. What's acting to the right? The big F, the force F. Since they're equal, that means friction is equal to 60 newtons, because we found F to be 60 newtons. Someone might say, oh, but they're not acting on the same object. Ya habibi, it's all the drawer. This is the big FBD. You're going to say, oh, this is acting over here, this is acting. Ya no, that's not how it works. As long as it's acting in your system, it's counted. So this is to the right, this is to the left, so what's on the left equals what's on the right, since they equal 0. And you're going to get F is equal to 60 newtons. Type. For part D, what is the coefficient of static friction? Always when we have coefficient of static friction, that means they want mu, right? And they asked us to find friction. So, what do you think you're going to use? Friction, how do you relate the friction to the mu, the coefficient? F is equal to mu times n, right? So 60 is equal to mu times n. Okay, but here we need to find n. What do we know about the vertical forces over here? We know that sigma fy, I'm going to go up, is equal to 0. Again, why am I doing this? Because, why am I doing this? Is because we're in rotational equilibrium. We use the first case, sigma m equals 0 for part B. We use the second case, sigma fx equals 0 for part C. And the last case, sigma fy equals 0, we're using it for part D. So sigma fy equals 0, what does that tell you? What's going up is equal to what's going down, right? So n is equal to w. That means n is equal to 160. So over here, 60 is equal to mu times 160. So mu is equal to 160 over 60, which is divided by 2, 8 over 3, which is, 60 divided by 160. Take it to the left, my bad. 60 divided by 160, you're gonna get 3 over 8, which is 0.375, which is to 2 decimal place 0.38. That's it. So that's a lot of talking, but to summarize, and I want to say it one last time, when you see something that says it's on the point of slipping and it may topple, that means you're working with rotational equilibrium, okay? And rotational equilibrium means you have 3 things, okay? Normal equilibrium means you have 2 things, and that's the sigma fy equals 0 and sigma fx equals 0. But when you came and added the word rotational equilibrium, what does rotation mean? It means moment. So that means also sigma m is equal to 0, okay? What cases do you use for what? This, you get the hang of it by practicing. If you don't know, just try. Sigma fy equals 0, you're going to see that n is equal to w. طب شو خاص هيدا بالf? Okay, try doing sigma fx equals 0. Like I'm saying, if, for example, for part B, let's say you didn't know what to use. Sigma fx equals 0, you're going to get f is equal to the friction. طب do you even know what the friction is? Do you even know what the friction is? Sounds like something else. Okay, F is equal to F. Do you know what the friction is to find F? No, we don't. So then you try your last case, sigma m equals 0, and you know it's around this point. So you know, oh, subhanallah, friction will cancel out because the moment of F is 0, and then the n will cancel out since the moment of n is intersection is equal to 0. So you're going to be left with that the moment of F is equal to the moment of W, and you can find the moment of W. Okay, it's starting to open up, starting to ring, the bells are starting to ring, tiftah, it's all starting to make sense. You're seeing you're getting somewhere, and then you're going to end up with n is equal to the moment of W. And you can find, F, moment of F is equal to the moment of W, and you find out what F is. So there's a lot of trial and error بالموضوع, but I don't want you to memorize. I want you to try, see for yourself, practice for yourself, okay? نصيحتي to you for mechanics, even for math as well. For mechanics and math, physics people and physics and chemistry people watch my videos and خلاص they go back to sleep. And they say خلاص توكلت على الله, and inshallah Allah بيسر الامتحان بيشرح لي صدري بالامتحان ويزيدني علما. Okay, that's completely fine, I guess. But for math and applied math mechanics, you really need to, like, as I'm working, pause the video, go back and try solving it yourself. That's how I learn, and that's how, for me, it works out for me. Okay, please don't just watch my video and go to sleep and just say inshallah. Okay, pause, go back, look at the question, try solving it on a paper by yourself. If you don't, go to the part you don't understand, see what I did there, and then continue solving. This is how you learn the concepts. Wallah, I'm serious. Okay, question 2. A uniform ladder of weight 200 newtons is resting against a smooth wall on a rough floor as shown in the diagram below. So we have a ladder, and you're going to see this question a lot in this quiz, and the ladder problem is a very common one. Maybe you might not get these questions in the exam, maybe the exam might come all grids, but the ladder question you'll see a lot in the material, a lot in the book, and a lot in every book actually. Anyways, drag and drop, the magnitude of the normal reaction by the floor on the ladder, by the wall on the ladder, and the friction. Okay, so what do we know about this ladder? We know that its weight is 200 newtons. We know that it's resting against a smooth wall on a rough floor as shown below. So it's resting. What does that mean? That means it's in what? Rotational. It's in equilibrium. You know what I mean? Just say equilibrium. Previously, when we used to work in chapter 4, or was it chapter 3? Maybe it was chapter 3. The one with forces. When we used to say it's in equilibrium, we used to have an object like this. We would say sigma fx is equal to sigma fx equals 0, and sigma fy is equal to 0 as well. Okay, this was what we used to have equilibrium. It would just be a particle, there's no rotation. Or if we used to have a car مثلا, right, it's resting on a horizontal floor. Here it's a ladder. انت think of it, is there a possibility to be moments? Why am I saying all this? Because then when I tell you equilibrium, you would want to know, do I test sigma m is equal to 0? Sigma m equals 0 is a case for every equilibrium. But how to know whether to use, like مثلا in the case I gave here with the particle resting on an inclined plane, try doing sigma m equals 0. What are you going to do sigma m equals 0 for? Is there any rotation that you can possibly see here? Okay, so my point is, because you're going to see in the exam, you're going to see questions from chapter 4, chapter 3, chapter 6. So and I'm sure you would want to know, do I use sigma m equals 0 in this case? Do I not? Okay, I think you should be able to figure it out on your own. Is there any moments? Here, of course, there's plenty of moments. You have a whole ladder. If this wall wasn't here, what's going to happen? It's going to rotate around this point and fall down, right? So I just wanted to establish that. When they say resting, it means equilibrium. Okay? In this case, what does that mean? Sigma fy is equal to 0. Sigma fx is equal to 0. And lastly, in this case, since it's a ladder, sigma m is equal to 0. طيب. What do we know? They gave us given weight is 200 newtons. What will people do? They're going to put weight over here. يعني I don't know what to tell you if you put weight over here. It's the weight of the ladder, it's 200 newtons. Where does the weight of an object act? It acts where? On its center of mass or center of gravity. Where is the center of gravity of this ladder? They told us it's uniform, so where is it going to go? Over here, right in the middle of the ladder. This is where the weight is going to act. Okay? Nice. So we found out where the weight is. What other forces are acting here? Because then I want to solve. How am I going to solve if I don't know all the forces? So the first step is obviously figure out its equilibrium. All your exercises will be equilibrium. The second step is, okay, and I want to apply these sigmas equal 0. To do that, I need to know all the forces acting. Let's see all the forces acting. This is what I'm doing. I started with the weight. Over here, obviously, there's contact with the surface. So what's there going to be if there's contact with the surface? The normal push, right? I'm going to call this normal push of the ground. You'll see why later, okay? They told us that it's a rough floor. What does that mean? It means there's friction. Someone's going to come and say, is the friction going to act to the left or to the right? Walid, how do I know? So think of it like this. If this wall wasn't, over here, if this was a smooth floor, where would the ladder go? It's going to slide to the left, right? So in other words, the friction is opposing the motion and it's pushing it to the right. صح? Again, the reason for this is because if this was a smooth floor, imagine, let's say مثلا, you try it on your desk if you're watching this on a desk, or I don't know if you're watching this on the toilet. Try placing your phone against a tissue box if you're on the toilet. It's more than likely gonna slide and fall like this, right? So what I'm trying to say is the direction of motion is it's gonna slide to the left. Since it's rough, the friction will prevent it and it's gonna push it to the right. Okay, that's why it's not sliding. Type. Most people are gonna stop here. They're gonna say, "Khalas, we're done. Let's start solving." No, my friend. Why are we not done? Over here, we have contact as well. So not only is there contact on the surface here, but there's contact here. This is another surface. So what's gonna happen here? Since there's contact, there's gonna be a normal push. So this is why I told you I'm gonna call this n of the ground, normal of the ground. This is, I'm gonna call it normal of the wall. Okay, now we have all our forces, we identified them. Let's start solving. What do they want? They want the magnitude of the normal reaction. In my opinion, there's no certain steps of solving. Like for chapter 3, and I would just do sigma fy, sigma fx equals 0. I'd solve, I'd get everything, and then I'll see what are they asking for, and I found it all. Okay, so I think, in my opinion, let's just start applying sigma fy, sigma fx, sigma m, and then see, match it with what they're asking. Okay, let's start with sigma fy is equal to 0. Let's see, what are my vertical forces? Ng and W. So Ng is equal to W. Type. What is W equal to? The weight is 200 newtons. So we found that the normal reaction of the ground, so by the floor on the ladder, is 200 newtons, and well, that's actually what they're asking for in part A. So we finished part A. Yalla, next, sigma fx is equal to 0. What are my horizontal forces? The friction and the normal of the wall. So F is equal to normal of the wall. Do I know anything about the friction? No, they didn't tell us anything. Do I know anything about the normal on the wall? No, again, they didn't tell us anything. So can I continue over here? No. When you reach a stage like this, it means stop. You don't have enough given, you don't have enough information to continue solving. So go to your next step. Sigma m is equal to 0. Let's do sigma m is equal to 0. What point are we going to take as our center of rotation? And to think about it, this ladder, when you push it left, push it right, around where is it going to rotate? It's going to rotate around here, right? So let's call this point O. Okay, we're going to call this point O, and this is where our center of rotation will be. So let's start with all our forces. Sigma n of the ground, sigma moments equals 0. So what would, my fault. Sum of moments is equal to 0. So we're going to find each moment and add them all up to be to 0, right? So let's start with n of the ground. Each force, we go to each force. So the moment of n of the ground around O, how much will it be? 0. Why is it 0? Because it intersects with O. If the line of action passes through the center of rotation, then it produces 0 moment, right? So this is the first one. The second moment, F, the moment of the friction around O, also will be 0. Why will it be 0? Since the line of action of the friction passes through O. Nice. Next, the moment of the weight around O. The moment of the weight of the ladder. Is it perpendicular to the force? Is it perpendicular? No. But if you extend the line of action, is it perpendicular? Excuse me, I'm just gonna do this. Write it on the side here, so you can kind of visualize what I'm saying now. Okay, the weight is over here. It's acting over here, right? It's going down. So, why did it close? Stop. Nice, it crashed. Okay, so I gotta rewrite all of this. Give me a sec. Okay, so I took down most of it again. I was saying over here, I was redrawing the diagram just so you can see what I'm talking about now. This is the ladder over here. Let me make it a bit taller so I can have more space. Okay, and this is the weight that's acting through the center of gravity, the center of mass, over here, right through the center, right? And this is our point O. This is our point O over here, right? My point is, although it may not be perpendicular to the force, but if you take a look, draw a line through here, it's already perpendicular. So we don't need to resolve any further. So the weight, we don't need to resolve it, and we already have this distance. We don't have this distance actually. You know what this is? This is a tricky part. You know, I'll talk about this now in a second. Okay, so we said we don't need to resolve the force. We just need to take the force and this distance over here. So let's do it. The force of the weight is how much? Remember that moment is equal to plus minus Ft. Before I continue, let me choose the direction. Since it's going like this, it's going to be clockwise, so it's going to be negative. The force of the weight is how much? 200 newtons. So 200 times this distance here. Okay, this, I'm going to just call this D. We can continue solving, and then we can come back to it. But I think what do I do? I think خلاص, let me tell you what D is. Okay, we'll do D now. Now they didn't give us anything about the lengths. Okay, so it's not correct for you to call this here L. Since we're working with a ladder, if they don't give you distance, you just call the length of the whatever you're working with, you call it L. Type enter, you need to know how much is D here, right? You need to find the D. Anyway, you need to figure out what D is, right? Type, you have a triangle over here. The angle here is 37 degrees. How much is the hypotenuse here? We know this acts in the center, so if this is all L, then here it's over here, it's L over 2. Okay? It's L over 2. So if this is L over 2, I need to find this D over here. We want the adjacent side. How do you find this side here if you know the hypotenuse is L over 2 and you have the angle? We want the adjacent side. We have the hypotenuse. What do? We know that cosine of 37 in this case is adjacent over hypotenuse, right? Therefore, you can easily find the adjacent side D. So D, which is the adjacent side, is equal to the hypotenuse L over 2 times cosine 37. So now, as D, you need to say the moment of weight around O is minus 200 L over 2 cosine 37. Type. Someone might stop here. You're gonna say, you know what this guy's doing is completely wrong. How does he have L if we're trying to find a force? How are you gonna solve if you have L in the equation? You're gonna see that they're gonna cancel out. Okay? Don't stop and say, what I'm doing is wrong. Habibi, continue solving. Continue until the end. Okay? Anyways, so we got this as our moment for the weight around O. Nice. Let's continue. We're not done. We have one more force left. We have the moment of the normal of the wall around O. Let's see. أول شيء, it's gonna go around. Yeah, I'll use this diagram so better. It's gonna go around like this. So it's gonna go counterclockwise. So it's positive. The force, we don't know it, right? It's actually one of the answers. Yeah, so I cut off again, but I think I stopped over here where I was finding the moment of the normal of the wall against O. We figured out it's positive. I definitely said that. it's equal to FD, so it's just going to be the force times distance. The force in this case is the normal, so NW times the distance. Let's see, is it perpendicular? Over here, it's not perpendicular, obviously, right? But if you go, if you extend it over here, if you extend this, and you extend O up, it's perpendicular, right? So now we want this distance over here. So again, you need to find out what this distance is. But I'm going to use this over here again because I feel like it was useful. Okay, so now we extended this. We said it's perpendicular from the center O. We want to find this. This is our new distance D here. Okay, we want to find this D. Okay, in other words, we're finding this. Since I already drew the triangle, I'm going to just find this. Okay, this is the same as this. They're the same. Okay, so it's the normal of the wall times D. Again, we need to put it in terms of L. Since this one we put it in terms of L, you have to put this in terms of L. Someone might say, why don't you just keep this as D and this is as D? Okay, then they won't be the same thing. Okay? Anyways, let's find out what D is. Okay, I'm going to erase the weight over here. Okay. I know that this over here is L. Same idea. I want to find the opposite side. I know that the hypotenuse is L. Opposite hypotenuse. What am I using? Sine. So sine 37 is equal to D over hypotenuse. Opposite, sorry. Therefore, D, which is the opposite side, will be equal to sine 37 times the hypotenuse L. Right? In this case, the hypotenuse is L, not L over 2 as it was previously. Okay, so L sine 37. So let's continue writing this. The moment of the normal of the wall against O is going to be NW, the force, times the distance, L sine 37. Okay, so we now figured out all our moments. The first two are 0. We're left with this and this. So, applying sigma m equals 0, that means when you add them on up equals 0, that means minus 200 times L over 2 cosine 37 plus NW times L sine 37 is equal to 0. Type, okay. Let's solve this. I think it's very easy to solve this. L over 2 times 200 is going to be minus 100 L cosine 37 plus NW L sine 37 equals 0. Type. Let's take the minus 100 L cosine 37 to the right. You're going to be left with, I'm going to continue up here, okay? NW L sine 37 is equal to 100 L cosine 37. Look at that. You can divide by N on both sides and cancel. So you're going to get NW sine 37 is equal to 100 cosine 37. How do you find NW? NW is equal to 100 cosine 37 divided by sine 37. Let's do it. 100 cosine 37 divided by sine 37. You get 132.7 newtons. Okay, where am I? So that means NW is equal to 132.7 newtons. Not very easy, but you just have to find moments. There's nothing complicated about it. So we found part A, we found part B. We figured out part A over here, remember? So now they want the magnitude of the force of friction. So now here, remember, in sigma fx, we stopped over here. I'm going to erase this. Okay, gonna take this down here. 132.7 newtons. Okay, over here we said that F is equal to NW. So we stopped because we didn't know what NW is, but now we found NW. So can't we doesn't that mean that we can find F? Since F is equal to NW and we know that NW is 132.7, that means F is also equal to 132.7 newtons, and that is what they're asking for in part C. So that's it for this question. Question 3. Oh, nice, got me out. Okay, question 3. Not hard, not very hard. A rod, so we're working with a rod now. I think it's easier than a ladder when a ladder working with angles, some people find it complicated. Anyways, a rod is acted upon by 4 vertical forces as shown in the diagram below. 2 up and 2 down, as you can see. The magnitude of F2 is 3 newtons and F3 is 7 newtons. The condition for equilibrium written by taking moments about the left end of the rod. Okay, and they want, okay, this is very easy. They give us all the distances, 2 meters, 3 meters. So they told us F2 is 3 newtons, and they told us here F3 is 7 newtons, and they want us to find F1 and F4. Now, without looking at this, how do you approach a question such as this? They told us that it's an equilibrium. Okay, so what does that mean? Sigma Fy is equal to 0, and sigma Fx is equal to 0, and lastly, sigma m is equal to 0. I think in this case, it's obvious that you're going to use this. Okay, but let's start. If sigma Fy equals 0, that means F1 plus F4 is equal to F2 plus F3, right? What's up is equal to what's down. So that means F1 plus F4 is equal to 10 newtons, because it's 3 plus 7. And this is, by the way, what they're asking. They're asking you to find F1 and F4. Okay, so without looking at these parts A and part C, you can figure it out. Type, if you do sigma Fx, there's no horizontal forces, so we're just going to skip this. And sigma m is equal to 0. When you do sigma m equals 0, by the way, you choose, if it's a rod rotating, you choose your own center. So you could take it here, doesn't matter. You could take it here, you could take it right here, doesn't matter, right here, wherever you want. But how do they teach us to do it? They teach us to take the center of rotation on the point where you don't know the force. So I don't know F1 or F4. So I'm either going to take my center rotation at F1 or I'm either going to take it at F4. Why am I doing this? Because how am I going to solve if I have two unknowns, F1 and F4? When I do sigma m equals 0, I'm going to end up getting one equation with two unknowns in it. So for that, خلاص يا أخي حل. Okay, so for that reason, I need to eliminate one of my unknowns. And to do that, when working in a moments problem, just take the center of rotation at that force. Because now, since the line of action of F1 passes through the center of rotation, it's going to produce 0 moment. So only 3 forces here will produce a moment, 2 of which I know, so I'm going to be left with one unknown. And then I can find F4. And now if you know F4, we know that they add up to 10 newtons, so you just subtract 10 and then you can find F1. So, very easy. I think I explained the whole concept for you. Let's start part A. They want you to take the equilibrium. So they told you the steps, so it's very easy. So what's the equilibrium if you take the moments about the left end of the rod? So take this as your center of rotation. They're taking the left end of the rod. Take the left end of the rod. So they're telling you work with moments. So if you see the question in the exam, please don't do all this habal. Okay, just solve what they're asking you to do. Okay, if they're telling you equilibrium moments left end, بسرعة, don't waste your time. Sigma m equals 0, and we're calling this point, let's call the rod AB, because we're going to work with point B later on for part C. Okay, so we're taking the moment about A. If the moment about A is equal to 0, that means moment of F1 is obviously 0. Okay, the moment of F2 around A is how much? F2 will take it clockwise. Please remember, moment is equal to plus minus Fd, right? It's going to be clockwise, so it's going to be negative. What is the force of F2? They told us it's 3 newtons. By the way, it's already perpendicular, huh? They already gave us the perpendicular distance, and the force is perpendicular. Okay, so minus 3 is the minus, because it's clockwise, 3 because the force is 3, and the distance is over here 1 meter. So they gave you literally everything. ما عم بيتعبوك بالمرة. Okay, 3, moment of F3 around A. Again, it's perpendicular, huh? As you can see here. Okay, it's gonna go clockwise as well, so it's gonna be negative. Its force is 7 newtons. Its distance is 1 plus 2, 3 meters, so minus 21 Newton meter. Yeah, the fourth one is the moment of F4 around A, which is equal to, it's gonna go clockwise, counterclockwise, so it's gonna be positive. Its force F4 we don't know, we're trying to find it. والdistance تبعتها 3 plus 3 6 meters. Okay, so it's equal to 6 F4 Newton meter. Okay, we know that it adds up to 0, so that means, let's continue over here. minus 3 minus 21 plus 6f4 is equal to 0. Minus 24 plus 6f4 is equal to 0. Take the 24 there, you're going to get 6f4 is equal to 24, so you're going to get f4 is equal to 4 Newton, 4 newtons. Very nice, very easy. So you found part A and you found, part A, let me, they want the condition for equilibrium. So they basically they want this over here, okay? They want you to find all the moments. So for F1, it's obviously 0, we said it. For F2 around A, it's minus 3, where's F2? Yeah, it's the force F2, so they're saying in terms of the forces. Okay, so if I were to write this in terms of the forces, I wouldn't write this 3 or 7, I would write it F2, F3, and then over here, I wrote it like this anyways. Okay, so it would be minus 1 F2, yeah, and then minus 3 F3, and then plus 6 F4. So that's what they want it in this way. I think it's completely fine. Okay, so they're saying to take the moments like this, equal 0, and then they said find F4, and we found to be 4 newtons. Obviously, you can completely skip this part and skip to here. We know that they should add up to 10 newtons, because what's up should be equal to what's down. You know, Newton's third law. Every action has equal opposite reaction. No, it's not reaction. Maybe it's first law, inertia. I don't know, bro. I have no idea. Anyways, you can just do 10 minus 4, you get 6, but they want us to do it from the right, so we have no choice but to start from the right. This is how you practice. This is really, this is how you know, this is how you, by practicing. Okay, yalla, 1. Let's take now, we're taking the moments around what? The right end. So let's call it, we're taking the moments around B. Okay, so let's start. The moment of F1 around B, okay, this is the first one, will be, I'm going to write it in terms of the forces, okay, because that's how they want it. Moment of F1 around B, it's going to be going clockwise, right, if you look at the direction, as you can see. Okay, so it's going to be negative. The force F1 times the distance, as you can see here, it's perpendicular, so the distance is 1 plus 2 plus 3, 6 meters. Okay, so we can say minus 6 F1, since that's how they want. 2, the moment of F2 around B, it's going to be going like this, so it's going to be counterclockwise. It's going to be positive. F2 times the distance, the force is F2, times the distance, 2 plus 3, 5. So it's going to be 5 F2 as the moment. 3, the moment of F3 around B is going to be equal to F3, also it's going to be going counterclockwise. Mazboot. So it's going to be positive. The force F3, since I told you we're going to write it first in terms of forces, then substitute. Force F3 times the distance, 3 meters. So it's going to be 3 F3. Lastly, the moment of F4 around B, which is just going to be 0. So we could just say 0 F4. So we know that they all add up to 0. So that means minus 6 F1 plus 5 F2 plus 3 F3 plus 0 F4 equals 0, and this is what they're asking for over here. Substitute what we know. Assume you don't know what F1 is. We're trying to find it. Assume that we're trying to find it, right? So you're gonna get minus 6 F1 plus, we know F2 is how much? 3, right? So 5 times 3, 15, plus 3 F3, we know F3 is 7, so it's going to be 21, plus this is 0. You're going to get 36 is equal to 6 F1, so F1 is equal to 6 newtons. Why are they doing all this? Why are they telling you to find this, telling you to find this? In the exam, you're never going to see something like this. You're just going to see, they might not even give you this or this. They're just going to say what is F4 and what's F1. That's what you're probably going to see in the exam. The reason for the question being asked like this is because they want to teach you that, oh, you can either take it, you can take your center from the left, or you can take it from the right. But the whole point is take it from the point where, take it from the point such that the line of action of the force you're trying to find intersects with this center of rotation, so that you can eliminate one out of your two unknowns, and then you can finally solve. Okay, if you only had one unknown force, then Ali, there's no point there. You shouldn't do this. But why are we doing this? Because we have two unknown forces, and you can never solve any equation with two unknowns. Okay. Question 4. Two ropes, as shown in the diagram below, hold a 300 Newton uniform plank of length 2.0 meters. A person of weight 500 newtons stands 0.5 meters away from the plank's left end. The angle the plank makes with the horizontal is 30 degrees. Drag and drop the correct the terms. They want you to find the tension in the left rope and the right rope, and if the angle of the plank's elevation increases, what will happen to, okay, so let's take a look here. Okay, so obviously here we have an equilibrium. Well, it's not obvious, but yeah, they're pretty much telling you, you know, yeah, this is holding it. They said that the ropes are holding it, and you know, they have a person standing. They didn't say it's moving at all. When they tell you it's moving or accelerating, that's when you assume that it's not at equilibrium. Anyway, in this case, also we weren't taught to solve anything other than equilibrium. So in this case, it's at equilibrium. So what three things do we have? Fy is equal to 0, sigma fx is equal to 0, and the third is that sigma m is equal to 0. Type. Let's start with sigma fy. Okay. Also, before doing this, I have to resolve the forces. I don't know what I'm doing. Okay, let's start. I think I should use over here a bigger diagram because the diagram is sort of small. I'm gonna draw the rod. Heck. Okay. I'm gonna draw the man here. I'm just gonna refer to him as a point object. Okay. And I'm gonna draw over here. This is one tension. Okay. We're gonna call this T1, and you have a second tension over here, which is T2. You have obviously the weight of the plank. They told us it's uniform, for the weight will act halfway through of the plank. Then you have the weight of the man, right? What other forces could we have over here? Okay, so I wanted to check if there is a normal force over here, because I wasn't sure if this was resting on the ground, then there should be a normal. But in this case, there's no, because it's not resting on the ground. This is just hanging. They only put the 30 degrees here to show you, oh, if you look at it, it's making a 30-degree angle like this. Okay. Anyways, so we now resolved all our forces. We know it's an equilibrium, so we know the three cases. You just do summation, you do sigma, and we just start solving. So let's start. First step, sigma fy is equal to 0. What does this mean? Everything that's up is equal to what's down. So T2 plus T1 is equal to W of the man plus W of the plank. So T2 plus T1 is equal to 800. Because this is, they told us his weight's 500, وهو هيدا البلانك 300. Anyway, so this is the first thing. We can't really do much with this. Okay? Second thing, sigma fx we can't. There's no horizontal forces. The second thing, that means we skip. We go to sigma m is equal to 0. In this case, we have two unknowns. Tension in the left rope, tension in the right rope. When we have two unknowns, what does that mean? When working with moments, you always have to choose your center of rotation, right? We're talking about moments around what point? Like I repeated twice, we had two questions on it. When you have two unknowns, what do you do? One question, actually, this is the second question. What do? You have to take the center of rotation either at one of these points. They're asking first for the left rope, so let's just put the center of rotation on the right rope. So this will cancel T1, and we can find out what T2 is. So let's start. We're going to take the moments around, let's call this point A. Around A. The moment of T1 around A is obviously 0. The moment of the weight of the plank around A. Let's see. It's gonna go counterclockwise, so it's going to be positive. Remember that m is equal to f times d. Type over here, use red for this, blue. Over here, it's going to be perpendicular. So do we need to resolve the force? No. So it's going to be WP, it's going to be positive. WP, the force, the weight of the plank, which is 300, times this distance, this perpendicular distance. How much is this? We know that this over here is 1.0 meters. How do we know it's 1.0? Because they told us the whole thing is 2 meters. The weight of the plank acts, since it's uniform, it acts at the middle of it, in the center, right? So it's going to cut it into 2 halves, 1 meter and 1 meter is in the center. Okay? We know it's 1 meter. How do we find this over here? They told us that the angle this is 30. Okay? How do I find this here? I have the angle, I want the adjacent side, I have the hypotenuse. What do? We know that cosine 30 is in this case going to be equal to adjacent over hypotenuse. The adjacent side here is the distance d that we want. So it's going to be cosine 30 is going to be equal to d over the hypotenuse, which is 1. So d is equal to, in this case, cosine 30. So that means the distance we're going to use here is cosine 30. So the moment is 300 cosine 30. Next, moment of the weight of the man around A. Again, the direction of it will be counterclockwise, so it's going to be positive. The force of it, the weight of the man, is 500. What's the distance? Again, if you take a look, let me erase shortly, hold on. It's too crowded. If you take a look, if you extend A, it's going to be perpendicular, right? So do we need to resolve? No. So we take the force as it is, 500, but we need this distance over here. How do we find this distance? Same way, same exact way. You know that this distance over here is, let me erase this. Oh, okay. Let me fix this. Okay. We know that this distance over here is 1.5 meters. Why is it 1.5? They told us this is 0.5. The whole thing is 2. Subtract them. That means you only have 1.5 left over here. Type. So this is 1.5. I want this bottom part over here. So I have a triangle. Have the hypotenuse is 1.5. Have the angle here is 30. I want to find this distance here. Same exact method that we used over here. We know that cosine 30. I want the adjacent side. I have the hypotenuse. I have the angle. What's adjacent hypotenuse? Cosine, right? Is equal to the adjacent side over the hypotenuse. The adjacent side is this capital D we're looking for, over the hypotenuse 1.5 is equal to cos 30. So that means D, this distance we want, is 1.5 cos 30. Okay, so what we're going to put here, 1.5 cos 30. Okay, I'm just going to keep it as this. Okay, moment of T2 around A is going to be equal to what? I'm gonna fix my diagram, okay? Okay, I think this looks a bit more presentable. The moment of T2 around A. Let's first check the direction. T2 around A, we'll pull it like this. It's gonna go clockwise, right? So it's gonna be negative. The force of T2, we don't know, we're trying to find, right? Times the distance. How much is this distance here? Again, if you extend T2 and you extend, since it's clockwise, it's gonna be minus, again, I cut off. It's going to be minus T2. Since we don't know what the force is, I'm going to write it as T2. And the distance is, we know that the whole thing is 2 meters. And we want this over here. Let's just call D again. So it's a triangle. Hypotenuse is 2. This is D over here. You want this angle, we know this angle is 30. We want the adjacent, we have the hypotenuse. For adjacent hypotenuse, we're going to use cosine equals adjacent D over the hypotenuse 2. So you're going to get that D is equal to 2 cosine 30. Okay, so we know now, we found all the moments, we know that they add up to 0. So what do? Let's add them up. 300 cosine 30 plus 500 times 1.5. Let's just do that. How much is 500 times 1.5? 750 cos 30 minus 2 T2 cosine 30 equals 0. Let's take this to the other side. You're going to get 300 plus 750 is 1050 cosine 30 equals 2t2 cos 30. Obviously you can cancel cos with cos. You're going to get cosine cosine. You're going to get 2t2 equals 1050 and t2 equals 525 newtons. Okay, you know from resolving the vertical forces that t2 plus t1 is 800. So if you know that t2 is 525, do you have to take t2 as your center of rotation and resolve and find moments again? No, it's too much work. So all you have to do is, since you know they add up to 800, 800 minus 525 equals 275. So you know that how much is this? This is t2 and this is t1, 275 newtons. So part A done, part B done. They're saying if the angle increases, how much will the tension, what will happen to the tension of the left rope? Type over here, it's gonna remain the same. Why? When you get something like this, ask yourself, how much is the tension of the left rope? How did I find it? I got that T2 is equal to, I got this, right? I got 2T2 is equal to 1050. How did I get it? Did I have anything to do with angles in my final answer for T2? Look at it. I got T2, 2T2 is equal to 1050. خلاص, just like this. مش أنا I cancelled the angle with the angle, the cosine with the cosine. Since they cancelled out, that means for whatever value of the angle, it's gonna end up cancelling out over here, and you're gonna get the same value of the tension every single time. Okay, so that's why it's gonna end up remaining the same. It won't change. So change the angle as much as you want. Okay, for question 5, you have a plank of length 1 meter and weight 1000 Newton held at 60 degrees, and by means of a vertical force F, the center of mass is located 0.4 meters from its lower end. So they told us this is where the center of mass is. Okay, what is force F? Very, very easy. So it's obviously in equilibrium here, right? So where am I here? Yeah, but it's obviously here, it's in equilibrium, right? Because it's being held, it's not more. All of these are in equilibrium. So since it's equilibrium, we have 3 cases: sigma Fy equals 0, sigma Fx equals 0, and sigma M is equal to 0. طيب, let's start. Sigma Fy equals 0. Let's first resolve and find all the forces. There's nothing here other than over here. Here, they're showing you the surface, so it's at rest. So since there's a surface, there's gonna be a normal push. Okay, you have to know that. In the previous question, there was no surface. They just said horizontal, حطوا لك 3 dots sake. Okay, so it was just to show you that there was an angle. Anyways, let's do this now. So here you have the normal push, you have the weight over here, and you have the force there. It's vertical. So sigma Fy equals 0. That means N plus F is equal to W. Alright? So N plus the force F is equal to the weight 1000 newtons. 2 sigma Fx is equal to 0. We skip this because there's no horizontal force. 3 over here, sigma M is equal to 0. Right? Guys, don't forget vector symbols. Anyway, so let's start. Where are we going to take the point of rotation? We know that we have 2 unknowns, N and F, and they're asking for both of these, by the way. So for that reason, you must take the center of rotation at one of these points. We're going to take it over here, because they gave me the distance 0.4 meters with respect to this point, so I might as well just take that as the center of rotation. So let's start. We're going to call this point A. Moment of N about A is equal to 0, right? Because it intersects with the center of rotation. The moment of the weight around A is equal to what? Remember, moment is equal to plus minus Fd. In this case, it's gonna go clockwise, so it's gonna be negative, right? The weight is 1000 newtons, and the distance is how much? Let's take a look. أول شيء over here, I'm gonna expand it a bit. Okay, over here. I have my weight going like this, right? So it makes a right angle. So I don't need to resolve the weight. It's also it's vertical. But you need to find this perpendicular distance. You need to find this. What do we know? We know that this is 0.4 meters over here as the hypotenuse. We know that this angle here is 60 degrees. How do we find this over here? It's gonna be 0.4 cosine 60. But how did I get it? You have a triangle, hypotenuse 0.4, angle is 60. How do you find this length? Remember, adjacent side, hypotenuse. What does that mean? We're using cosine. So cosine 60 is going to be equal to the adjacent over hypotenuse 0.4. So how do you find L? 0.4 cosine 60. I got used to it because of the amount of questions that I've solved about this, that I've seen, where you need to find, or you need to use trigonometry to calculate the length of this side. Because I memorized it. If you want the side that's under it, knowing the hypotenuse, I just said, oh, this side is always, this side is always hypotenuse cosine alpha. No, I just memorized it, okay? You can get used to it as well, but in my opinion, draw the triangle. It takes you 5 seconds, okay? So this distance, how much will it be? 0.4 cosine 60. Okay. Next, the moment of the force F about A. Our sheet is going to go counterclockwise, so it's going to be positive. The force F, we don't know how much it is. What's the distance? Let's take a look over here. Force F, if you extend it and you extend this, they're perpendicular, so no need to resolve, right? So we take F as it is. But what's the distance? We need to find this perpendicular distance. How much is it? Same idea. Triangle. The length of the hypotenuse is 1 meter. We want to find, they gave us the angle, we want to find the adjacent side. Same procedure as this. So you're going to end up getting, if you follow what we did here, this adjacent side is going to be 1 cosine 60, which is cosine 60. So here's going to be cosine 60. Okay, we found all the moments, so we know that sigma m equals 0. So negative 1000 times 0.4 cosine 60 is equal to f cosine 60. We can cancel cosine with cosine, so you're going to get f is equal to negative 1000 times 0.4. What? It's this, let me repeat the step. You add them all up to get 0, right? So negative 1000 times 0.4 cosine 60 plus f cosine 60 is equal to 0. Take this to the other side, you're going to get f cosine 60 is equal to 1000 times 0.4 cosine 60. You can cancel cosine with cosine. You can get f is equal to 0.4 times 1000, which is obviously 400 newtons. To find the normal reaction, do we solve again and take the center of rotation as f to find n and resolve or whatever? No. We know that they should add up to 1000. So therefore, you can just plug in f as 400. You're going to get n is equal to 1000 minus 400, which is 600 newtons. Very easy. Type. Moving on. If it wants to load, give it a sec. Okay. Oh, what is this? Back. Okay. A uniform 100 centimeter plank of weight 120 newtons is placed on 2 stands. So they told us the weight is 120 and they told us it's uniform. Anyway, we have stands A and B located 10 centimeters and 30 centimeters from the plank's ends, respectively. And they told us it's fully 100 centimeters. The plank rests in equilibrium. Find A and B. This is a grade 10 question, so I'm gonna fly through this, inshallah. So let's calculate all the forces. Awal shay, they told us it's a uniform plank and they told us the weight is 120. So where is the weight gonna act? It acts on the center of gravity, right? So since it's uniform, the center of gravity is just gonna be over here in the middle. So this is the weight. Type. Do we have any other forces acting here? No. So we know it's resting on 2 stands A and B. So we're gonna call this normal A, the reaction of A, and reaction of B, right? Yalla, since it's in equilibrium, what do we know? Sigma Fy is equal to 0, right? So that means what's up is equal to what's down. So NA plus NB is equal to the weight. So NA plus NB is equal to 120. We can say sigma Fx equals 0, but here there's no horizontal forces, so we can just skip it. So we're going to skip directly to sigma M is equal to 0. Yalla. What are we gonna take as our center of rotation? Since we have two unknowns, NA and B, we have to take one of these points as the center of rotation. Let's take NA as the center of rotation. Okay, so let's see. We're going to talk about, we're going to call this point A. We're going to take the moments around A, we're going to say that they equal 0. The sum of moments around A equals 0. Yeah, let's start. Moment of NA around A is obviously 0 because it intersects with the line of action. Moment of the weight around A is how much? When you continue it, it's going to go clockwise, right? So it's going to be negative. Remember that moment is plus minus FD. Negative. The force of the weight is 120. With the distance is how much? If this is 10, this is 30. That means how much is left over here? 60. Right? Type, okay, without the 60. We know that this acts in the midpoint. So here it's going to be 50. It's going to divide into two equal halves, 50 and 50. So we know this is 30, but this whole half is 50. So it's going to be 20. And we know this is 10, and this whole half, it's divided 50. That means here it's going to be how much? 40. So the distance between WP and A is 40 centimeters. So how much is the distance in meters? 0.4. So it's going to be negative 48. Type, the moment of, hello, we're left with NB about A. It's going to be going, if you continue it, counterclockwise. Okay, so it's going to be positive. The force NB, we don't know it. The distance is how much? Over here, we figured out this is 20, and this is over here 40. So 60 centimeters, so in meters is 0.6. So 0.6 NB. We know they add up to 0, so that means minus 48 plus 0.6 NB is equal to 0. So you're going to get 0.6 NB is equal to 48. Means NB is equal to 80 newtons. Nice. To find NA now, we got squared. Find NA. Do we resolve again with respect to B and solve again? No. We know that they should add up to how much? 120. So I can simply do NA is equal to 120 minus NB, which is 120 minus 80, which is 40 newtons. Thank you so much for watching, and good luck in your exam. Wait, before going over here, the only hard part was just the weight, huh? So you just had to divide this into 50 and 50. If this is 10, that means the rest of this will be 40, and if this is 30, that means the rest of this will be 20. I think that's the only hard part, huh? Anyways, now thank you so much for watching, and good luck in your final or whatever.